Okay, class, welcome to day 3 of e-learning. Today we're going to talk a little bit about law of sines, which I kind of hinted at in one of our previous lessons when we were trying to solve a right triangle. So if we come back to this example, and again, this was one that we ended with when we were solving right triangles, we talked about how we would not be able to solve this one by using SOHCAHTOA since we did not have a right triangle. There's one piece of information we can get. We know that all the angles in a triangle do add up to 180 degrees. So if we subtract the 85 degrees that we already have, we do know that this angle is 95. But again, since we don't have any right angles, we're not going to be able to have any method of actually solving for the two remaining sides without a little bit more information. Going back to what it means to solve a right triangle, or to solve a triangle, it means to find the lengths of all the sides and the measurements of all of the angles. So as we look at this, there's going to be 3-4 different cases that we look at. Today, we're mostly going to be looking at case 1, which is where we're going to be having two angles and one side. The side can either be between the angles or it can be outside of the angles. Now, later on, we're going to be getting into the rest of these cases. We'll see a little bit of those today. This is where we have two sides and at least two sides and possibly one angle, depending on the situation. In these cases, things can get a little bit trickier, and we'll talk about that as we get to them. So the law of sines. Before we look at what the law of sines says, I did like to do a quick proof of where the law of sines comes from. If we took this triangle and drew the altitude, altitudes or heights have to be perpendicular to the base, we could call this the height. If we then said, look at angle A, and I wanted to find the sine of angle A, I could find the sine of angle A by comparing the height to the hypotenuse. So the sine of angle A would be h over c. If I came over to the other side, I could do the same thing with angle C and say that the sine of angle C is the opposite, h, over the hypotenuse A. Now, in both cases, since both of these equations have h in them, I'm going to actually solve each equation for h. So if I multiply both sides by c, that would give me h to be sine of A times c. If I do the same thing on this side, multiply each side by a this time, that would give me h to be sine of c times a. Then, because both of these are equal to the same thing, using substitution, we can set these two equal to each other. So if we said sine of A times c could be equal to sine of c times a. Then, if I divide both sides by c, that would allow these c's to cancel. If I divide both sides by, switch colors, if I divide both sides by a, that would allow the a's to cancel. And so my final equation says that the sine of a over a equals the sine of c over c. And this is the law of sines. Now, if I was to extend it and looked at angle B and drew an altitude from a different location, I could prove the same thing with the sine of B as well. So the law of sines comes down to this. If I take any angle in a triangle, angle A, angle B, or angle C, and I write the ratio comparing the sine of that angle to its opposite side, it will be equal to any of the other the sines of any of the other angles compared to their opposite sides. Now, the one thing I mentioned before is that there are going to be some interesting cases that are what we call ambiguous. And we're going to get to those a bit later. But I'll tell you that an ambiguous case happens when we are given at least two sides of the triangle. And when that happens, there are 3 different possibilities. There could be a situation where there's no triangle formed. There could be a situation where only one triangle is formed. And later on, maybe not tomorrow, maybe after break, we're going to look at situations where maybe 2 triangles could possibly be formed. One thing to make sure that you always do is check your angles. Remember that the angles of a triangle must add up to 180 degrees. If that doesn't happen, then you're going to have to get rid of that possible solution. Okay, so let's go back to that first problem from the other day. Now that we know the law of sines, now we can actually solve this triangle. Remember that we already figured out this third angle would be 95 degrees. So with that information, we can write three proportions. Now remember that if this is angle A, the side across from it is angle A, or side A. If this is angle B, the side across from that is side B. So I can actually write the following three proportions. The sine of 95 degrees, that's angle C, compared to the side opposite, equals, I can write a proportion using this angle, the sine of 45 degrees, to the side opposite it. And then my last ratio would be the sine of the 40 degrees compared to the side opposite it. Now we need to be able to solve ultimately for sides A and sides B. So find the one ratio where you know the complete proportion. That's going to be this first one here. And we'll start by solving this proportion or this equation. Because this is a proportion, we can cross multiply, which means that if I multiply the sine of 95 degrees times side A, that will equal the sine of 45 degrees times side 4. To solve for A, I will do the sine of 45 degrees times 4 divided by the sine of 95. Make sure that your calculator's in degree mode, and when you put that in, the sine of 45 times 4, I would recommend hitting enter and then dividing by the sine of 95 in a second step. And our A value is approximately 2.84. If we come and repeat the process now, go back to this same ratio where we knew both the numerator and denominator, and now we'll set it equal to this one and solve. So the sine of 95 over 4 equals the sine of 40 over B. If we cross multiply, the sine of 95 times B equals the sine of 40 times 4. And to solve for B, we will divide by the sine of 95. So B is approximately sine of 40 times 4 divided by sine of 95. Oops, I made an error. Remember that after you do the sine of 40, don't forget to close the parentheses before multiplying by 4. And again, I would still recommend that you divide by the sine of 95 in a separate step. And we get a B value of approximately 2.58. Now, I do always like to check. One thing with triangles is that the side across from the smallest angle should be the smallest side. So I like to see that that 2.58 is smaller than the other two. Just a quick way to check your work. Okay. Oh, by the way, this particular case was not ambiguous, because to be ambiguous, you have to be given two sides, and we were not given two sides. Okay. Second example. Once again, always ask yourself, is this an ambiguous case? Because if it is, we're going to have to look at a few more details. But again, in this example, this is not ambiguous. We are only given one side, and that's side 4. So we don't need to check out any unusual situations. But again, remember, we're going to need to find this missing third angle before we start writing our ratios. So since the angles do have to add up to 180, we can subtract the 100 degrees that's given, meaning this angle is 80 degrees. The side across from that is side C. The side across from the 60 degrees is side B. And now we can write our three ratios. Doesn't matter what order. I'm going to say the sine of my 40 degrees over 4 equals the sine of 60 degrees over B equals the sine of 80 degrees over C. Pick one pair of ratios to solve originally. So if we solve this one, we will get, oops, I apologize, the sine of 40 times B equals the sine of 60 times 4. To solve for B, we're going to divide sine of 60 times 4 over the sine of 40. Sine of 60 times 4 divided by sine of 40. and we get b to be approximately 5.39. And again, if we repeat the process using the first completed ratio and the third ratio, sine of 40 over 4 equals sine of 80 over c. To find c, I will be multiplying the sine of 80 times 4 and then dividing by the sine of 40. So c is approximately 0.64. Now, looking at that, that doesn't seem correct. If we go back, the sine of 80 times 4, and it looks like side C is the largest angle, and therefore it should be across from, I'm sorry, side C is the, angle C is the largest angle, so the side across from that should be the largest side. Let's double check our calculations here. Sine of 80 times 4, and we're going to divide by the sine of 40. Oops, that's correct. This time it looks like the correct answer is 6.13. Here's the benefit of checking those sides. All I had done is type the wrong button in the calculator, which gave me that incorrect answer. But again, always check your sides. If you look for that largest angle, the side across from that should be the biggest side of the three. So if you check all three of your sides, you can see that this is the biggest side. This makes more sense than the original answer. Okay, as we look at this next one, is this an ambiguous case? In this case, it is. So when we solve the ambiguous case, different things may happen at times. For example, we have two sides in this case. However, we only have one angle, which means that we're not going to be able to start out with knowing the other angles by subtracting 180. When we start this problem, look for one complete ratio that you'll be able to write. So for example, this angle and the side across from it, I can start with that. Sine of 60 divided by 4 equals. Now, the only other thing I know is side 5. So I'm going to have to use that to solve for angle B straight across from it. If I said the sine of angle B over 5, this would allow me to solve for angle B. When I cross multiply, I'll have the sine of B times 4 equals the sine of 60 times 5. Then we can divide by 4, so the sine of B equals the sine of 60 times 5 divided by 4. Notice that I'm not using the calculator quite yet. To solve for a missing angle, we have to do inverse sine. And we're going to do sine of 60 times 5 divided by 4. This is going to be a lot to put in your calculator, so I would definitely say let's start by evaluating this part of it. Sine of 60 times 5 divided by 4, and we're going to get about 1.08. Now, anticipate what might happen when I try to do the inverse sine of 1.08. In other words, I want to know the sine of what angle will be 1.08. Now, if you're thinking about it, you're probably going to realize that when I try to put this in the calculator, it's going to give me an error message. And that's because if that ratio is over 1, there is no solution. This is an example of a situation where there is no solution, which means there is no triangle. This triangle is actually impossible to actually create with these given measurements. Okay, we're going to look at a couple of examples of some applications. This number 2 I'm actually going to skip. This has to do with something called bearing, and we're going to come back and talk about bearing again a little bit later, probably after spring break. However, if we look at this one, there's a lot of information in this problem that we're going to have to pick apart. Definitely going to be a multi-step problem. To measure the height of a mountain, a surveyor takes two sightings of the peak of the mountain at a distance of 900 meters apart on a direct line to the mountain. So we're going to take the sightings from these two locations, and these two locations are 900 meters apart. The first observation results in an angle of elevation of 47 degrees. So when this first person looks up to the top of the mountain right up here, that's going to be at an angle of elevation of 47 degrees. Remember that angle of elevation, you should always, always, always draw the horizontal first. So I'm going to draw in that triangle. And this angle is my 47 degrees. It says that the second sighting results in an angle of elevation of 35 degrees. So from this location, looking up again to the top of the mountain, draw in that horizontal. I have basically a second triangle here, and I know that that angle down here is 35 degrees. Now, the other thing they tell us is that the transit, that's the piece of equipment that they're actually standing on, the transit is 2 meters high. So keep in mind that there is an extra distance of 2 meters over here, and we want to know, ultimately, what is the height of the mountain. So we need to figure out this height. Unfortunately, folks, we have a lot of missing information here. We don't know how far these transits are from the actual mountain. This is unknown. We don't know the height itself, and we don't have either of these hypotenuse figures. That's a lot of information that's missing. But if we're very careful, and I know I didn't draw this really, really well, if we're very careful, you might notice that there is actually a third triangle in this picture right here. It's not great. But if you look closely, we're going to have this really skinny triangle up here that comes down and it comes over. I want to talk a little bit about that triangle. I'm going to kind of redraw it. So basically this little skinny triangle here. A couple things we know about this triangle. We know that this angle right here was 35 degrees, and we knew that this distance right here is 900 meters. Now, we could also quickly figure out this distance, because remember that these two angles right here add up to 180. So if I do 180 minus 47, that's going to give me that angle measurement of 133 degrees. Now, if I know these two angle measurements, this one and this one, then I should also be able to get this angle, since I know that all three add up to 180 degrees. So 180 minus 133 minus 35 gives me a small angle here of 12 degrees. Why do I want all this? Because ultimately, if I want to come back up here and find the height of this mountain, I'm going to need to know this hypotenuse so that I can use this right triangle to help me find that. The only way I'm going to find that hypotenuse is down here in this triangle by using my law of sines. So coming down here, the side I'm looking for is across from this 133 degree angle. So we'll start by saying the sine of that 133 degrees over, let's call it, I don't want to call it H, let's call it A, over side A, equals. Then you need to find the other set of information that you know. I know this side, and the angle across from it is 12 degrees. So I'll say equals the sine of 12 over 900. Solving this proportion will allow me to find that missing A value. So to solve for A, I will get the sine of 133 degrees times that 900 divided by the sine of 12. That's just my cross multiplying. And sine of 133 times 900 divided by sine of 12. That's going to give me about 3,165.8. Let's round that up to 3,166, just since we have a lot more steps to do. So what we now know is that this is 3,166. Bringing that back up to this picture, 3,166 meters. Now we can look at the big triangle. And I'm just going to highlight it in this purple again. Okay, so remember in this big triangle here, we're trying to find this height over here on this end. It might even help to redraw it. I'm looking for this height. I know that this angle was 35 degrees, and I now found that this was 3,166. Because I now have a right triangle, now I can just use SOHCAHTOA. The sine of 35 equals the opposite, my height, divided by the hypotenuse. And when I solve for the height by multiplying these together, I get a height of sine of 35 times 3,166. I get about 1815.9. Now, don't forget one last thing. We got to add 2 to that, since technically the transit was 2 meters off the ground. So the actual height of the mountain is 1,817.9 meters high. So these are nice, good, very multi-step problems where you might have to use a combination of skills. Just think about what information you're going to be able to find. Really look for all of those angles to help you find as much as you can. Okay, one last problem that I'll leave you with here. Observers are 2.32 miles apart, and they see a hot air balloon between them. So let's call this person 1 and person 2, and we know that they are 2.32 miles apart. Person 1 sees the hot air balloon at an angle of elevation of 28 degrees. So person 1 looking horizontally, person 1 looks up at 28 degrees. Person 2 sees it at 37 degrees. So there's his horizontal, there's that person looking up, this is 37 degrees. We want to ultimately find the altitude of the balloon, so this is what we're going to be looking for. Okay, but just like in the last problem, we will have a nice right triangle here, but without one more side, we're not going to be able to use that right triangle to be able to solve for the height. So the first thing we're going to need to do is look at our larger triangle, the main triangle in the picture here, and find this missing angle. Since we already know these two angles, if we subtract those from 180 minus 28 minus 37, we're going to get this angle of 115 degrees. Now, using these angles and the one side that we do know, we can use law of sines to find one of these two missing sides. Either one is going to work for us, so I'm going to go ahead and try to find this one. Again, always look for the one set of information that you'll be able to solve or to write a complete ratio. So I'm going to start with the sine of 115 degrees over the 2.32 that's across from it. Now, since I'm looking for this side, I'm going to have to use this angle that's across from it. So I will write the sine of 37 over the missing side A. And using cross multiplying, we can multiply the 2.32 times the sine of 37, divide by the sine of 115, and A will be approximately, divided by sine of 115, A will be approximately 1.54. So if I come back here, 1.54, now I can use my right triangle. Again, I'm going to highlight, here's that right triangle here. And this time I want to find H. So if I go back to this angle, the sine of 28 degrees is the opposite, my H, over the hypotenuse, the side I just found. And H is going to be the sine of 28 times the 1.54. 28 times 1.54. Looks like my H is about 0.72. Now that seems like a small number until you go back up and realize that that's miles. So what that means is this hot air balloon is about 3/4 of a mile up in the air. That seems a little bit more reasonable to me. Homework tonight, or what I'd like you guys to do to practice, is to try my math lab that I will have assigned. I will also assign a copy, just screenshot from the textbook, if you are having some difficulties with my math lab. But remember, class, the advantage of using the my math lab is that you can use the check your answers. You can see a sample problem if you're struggling with some of these. Especially these word problems can get a little bit tricky. So good luck, and once again, email me if you have any questions or want to go over any problems.